Okay, in order to convert to second normal form, we have to remove partial dependencies. Okay, just to give you overview of the previous lecture, we have two type of functional dependencies, partial and transitive. Partial dependencies exist when your non-prime attributes depends on only the part of the primary key. Like your primary key is a composite key and your other attributes does not depend on a full primary key but only a part of it. Then we have a partial dependency. So in order to convert to
Wait a minute.
second,
I
yes,
forgot to record.
no, I'm recording, don't worry, I'm recording
Recording?
from, yes. So in second normal form, we remove partial dependencies. Okay, how can we remove partial dependency? What is the way to do this? Write each key component on separate line and then original key on last line, and each component will become key in new table. Okay, so let's do it in a proper way. Here in the example, okay, this was our example that we were doing, and here we have partial dependencies, two partial dependency. Our primary key for this table was project number and employee number, and we have two partial dependencies over here. One is project name depend only on project number but has nothing to do with employee number, and employee name, job class and charges per hour depend on employee number and has nothing to do with project number. So we have two partial dependencies over here. So the first step is, when we are converting to second normal form, write each key component on separate line and then original composite key on last line. So if we look at it, you can see that we have what is our primary key over here? Project number and employee number. Okay, so our primary key is I don't know what's wrong. Okay, project number and employee number and then together employee number comma project number. Okay, and then underline them all. When you are converting to second normal form, first step is, this is your primary key, employee num, project num. You have to divide it, project num separate, employee num separate, and then your composite key separate. Now look at the attributes which are dependent on project num. As per our diagram, project name depend on project num, so we will add project name here with project num. Okay, now see which attributes depend on employee num, employee name, job class and charges per hour. So employee name, so I will add them like this: employee name, what was else, job class and charges per hour with employee num. Okay, and what is left now? The only attribute that left out of it, project name is depending on project number, and all other 3 depend on employee number. So only attribute that left is hours. So hours is going to be add over here in the last, the one that is left, hours over here. Okay, so now what we did is, initially we have one table, now we divide this one table into 3 tables. One table is project, another table is employee, and the third table is assignment. Employee number, project number, and hours. Which employee is assigned to which project and work on that project, how many number of hours. Okay, so now if you see in this form, there is no more partial dependencies left. So we have converted our database into second normal form. Okay, any question? And same thing is over here. All partial dependencies, we have 2 partial dependencies here. Project num depend on project name depend on project num, and employee name, job class, charging hour depend on employee num. So what we did is, when we want to convert to second normal form, write the all the, if you have composite key, you divide it into normal one attribute. Project num separate, employee num separate, and overall key separate. Okay, and then you add these attributes over there. Now we have 3 tables: project table, employee table, and assignment table, and we are in the second normal form. Okay, let's go for the next. Okay, so table is in second normal form when it is already in first normal form, and it includes no partial dependencies. And what it means by partial dependency, none of the attribute in the table is dependent only on a part of the key or portion of the primary key. Then our table is in second normal form. Now my question is, if I have a table where primary key is student ID, okay, only one attribute, student ID, will there be a partial dependency exist in that table? Okay, how to convert to third normal form? In third normal form, we eliminate transitive dependencies. What is a transitive dependency? When your non-key attribute depends on another non-key attribute. Normally, in fully functionally dependent system, each non-key attribute should fully functionally dependent on primary key, okay, or a prime attribute. Primary key we call prime attribute. But transitive dependency exists when your one non-prime attribute depends on another non-prime attribute. So how to eliminate transitive dependency? First step is, for every transitive dependency, write its determinant as a primary key for the new table. Like here, in this case, I have this transitive dependency. Okay, charges per hour depends on the job class. What is the job? Charges per hour depend on it. Job class is not a primary key, so it means it is a transitive dependency. So what should be the first step? Okay, what is a dependent and what is a determinant here in this case? Which attribute is determinant? And which is dependent? Okay, it is written over here. Which is dependent and which is determinant? Job.
The dependent is job class.
Yes, dependent is job hours or charges per hour, and determinant is job class. So you have to write determinant as a primary key. Okay, so in order to do that, okay, let's go to our board. First step, what we have to do is, what is the determinant? Job class. So this is my primary key. Okay, first step. Okay, what is the next step? For every transitive dependency, write its determinant as a primary key for new table. So we will divide this table into two new tables, okay, and job class will be the primary key of the new table. Okay, and then okay, what is a determinant? This is the just definition of determinant. What is the second step? Reassign corresponding dependent attributes. So what is the dependent attribute? Charge per hour. So charge per hour will become over here part of this table. So we created a new table over here where job class is primary key and charges per hour is the attribute over here. Okay, what happened to the original table? This table, we remove charges per hour and job class from both from over here? No, job class will remain over here. If we see, okay, reassign corresponding dependent attribute and name table to reflect its content and function. Okay, so this new table is related to job. It only gave information about job, so we give this new table a name, job, and job class remain in the original table as well. This was the original table, employee table, employee num, employee name, job class, and here job class become foreign key, and in this table it is a primary key. Okay, so how to convert to the third normal form? A table is in third normal form when both of these conditions are satisfied. First condition is it is already in second normal form and it contains no transitive dependencies. So second norm, okay, first, what is the condition for first normal form? First normal form mean no repeating groups. We have to remove the repeating groups and we have to identify the primary key of the table. So this is the condition for first normal form. What is the condition for second normal form? Table is in first normal form and there are no partial dependencies. Okay, what is the condition for third normal form? Table is in second normal form and there are no transitive dependencies. Clear? Any question? Okay, this slide I added new over here. I think you should know this. Integrity constraints. Okay, what it means by entity integrity? If we say that this entity satisfy entity integrity, it means it is required that every table have a primary key. In order to ensure entity integrity, a table must have a primary key, and when it has a primary key, it means neither the primary key or nor any part of it can have a null value, because a part of it in case composite key, if your primary key is composite, it doesn't mean that one part is okay, contains some value and other part is null. No, both part, if you have a composite key, both parts should have some value. It cannot have a null value. Why we are not allowing null value? Because primary key is used to identify the record or the row in the table. So if primary key is null, we would not be able to identify uniquely a record or the row in the table. Okay, this is called entity integrity. Okay, what is the definition of referential integrity? Very important concept. Referential integrity means that a foreign key must have a matching primary key or it must be null. Okay, like here in this example, we have two tables. One is customer table, another one is order table. Now in customer table, primary key is customer ID, and in order table, primary key is order ID and customer ID is the foreign key over here. Okay, now they said that if in any table, okay, which table have a foreign key? Order table has a foreign key. Customer table does not have any foreign key. Order table has a foreign key. So if a table has a foreign key, then that table should satisfy referential integrity. What it means by referential integrity? It means that if I'm adding any value for customer ID here in the order table, that customer ID should already exist in customer table as well. It's not like a customer ID does not exist in customer table and I'm adding it in a order table. Otherwise, it must be null. Okay, let's customer and order. Let's suppose this is my customer table, and in this table this is customer ID and other attribute, and this is my order table, and this table have order ID and customer ID. Customer ID is foreign key over here. Okay, I should write here also, see customer ID. Okay, let's suppose, okay, I don't know, I can, okay, 1 2, here I have customer ID number 2 3 and 4. Okay, here I have two record. Order ID is 121 and customer ID is 3. Order ID is 129 and customer ID 5. Now this 5 violate referential integrity constraint. Violate it. How violate it? Because 5 does not exist in the original table as a customer ID. This 5 is not referring anything here in the original customer table. So this thing is not allowed. This is not allowed. If you add some value in order table, the value of customer ID which does not exist in the original table, then it violate referential integrity constraint. Either you should make it null, okay, 0 is a value, null is like this, 0 is not a null. Null mean you write proper null over here, 0 is a value, okay. Either it should be null or it should be matching, but you cannot add anything here in the customer ID which does not exist here in the original table. Got it? That is called referential integrity constraint. Okay, we need to improve our table structure. Each time, like when you create a table structure, you need to clean up to eliminate initial, partial and transitive dependencies like we do in normalization. You know, when we do normalization, we eliminate partial and transitive dependencies. They said that normalization does not guarantee that every time when you perform normalization or when your table are properly normalized, they have a good design as well. Okay, normalization cannot by itself be relied on to make good design. This means that if you perform normalization, you're not sure that okay, after normalization my database is in very good design. So and this thing is valuable, but normalization is valuable. It is important. Why it is important? The purpose of normalization is to remove data redundancies. We don't want to have data redundancies in our database because it just increase the complexities of our table, and it takes more time to get answer of our query if we have lot of data redundancy. So normalization is good in that case, but normalization does not guarantee good database design. Okay, when we are going to improve our database design, there are some issues that need to address. First thing is you have to evaluate the primary key assignment. Okay, like here if we see this table, we have a employee table, this one. Okay, now each time a new employee is entered into this employee table, a job class value must be entered, or job. Okay, here they have improved it, change it to job code. Let's go back here. Yes, in employee table, every time when you have to add a new employee over here, you have to add job class as well. And it's too easy for data entry operator to make errors here that may lead to referential integrity violation. How? Like our job class is database designer, so your data entry operator can add database designer in two ways, like one time they enter database designer like this, db underscore designer. Another database designer is being hired and you have to enter the job class, and now database entry operator write it like this, database complete database designer, although meaning of both is same, database designer, but these two values are not equal, so there is a chance of referential integrity constraint violation in this case. So they said that when we improve our database design, like here, instead of job class, we add a attribute job code. Okay, to create a unique ID for each job. And here in the job table, instead of job class, we make a primary key job code. So job code here is a surrogate key that we added over here in the job table, so that if somebody wants to enter here in this employee table, they don't have to enter a full description of the job, just job code, a number. So when they have to enter a number, there is less chance of error as compared to writing a complete job description. Okay, so job code is added over here in the job table as a new primary key, although previous primary key was job description. Both are equivalently okay as a candidate key, but we choose job code as a primary key because it is more easy to manage it, and there is less chance of referential integrity constraint in case when we are performing a large number of data entry into the database. Okay, so this is first thing, evaluate primary key assignment. Okay, second is evaluate naming convention. Okay, if you see over here in the table, previously we call this charges per hour. Okay, charges per hour for what? So we have to add something like naming convention. We should prefix it with the name of the table, job charges per hour, so then it will be more better name. So we change this charges per hour attribute name from to job charges per hour. Similarly, job class. Now job class is not very good description what it is, so we change it to from job class to job description. And then hours, we change hours to assign hours, because only hours, what it means by hours, so we change it to assign hours when improve the database design, like here hour has been changed to assign hours, job class is changed to job description, and charges per hour is changed to job charges per hour. Okay, refine attribute atomicity. Now what it means by attribute atomicity? An atomic attribute is that attribute which cannot be further subdivided. and we have seen this when we discuss attributes. And if attribute cannot be further subdivided into smaller parts, then we say that it display atomicity. Like if we go back here, employee name. Now employee name is not a atomic attribute. Employee name can be further subdivided into employee first name, employee last name, and employee initial. So if you see any attribute like, okay, this attribute is not an atomic attribute, then divide this attribute into its sub part and each part become a new attribute. Like here, if you see now in the employee table, we change employee name into 3 attributes: employee last name, employee first name, and employee initial. Okay. Then identify new attribute. Okay, according to like here, this original report, the user need to track which employee is acting as the manager of each project. Like if we want to know that each project have one project manager. Now if we want to know that from employee table which employee is the manager of a project, so this information currently in this form we cannot get it. So how can we get this information? If we create a relationship between employee and project, that is an employee manage a project. Okay, so in that case each employee manage a project. So employee num can be added as a foreign key over here in the project table to show the relationship between project table and employee table. So this is what we did when we improved the design. Here employee num is added in project table as a foreign key to show the relationship between employee and project. Okay, what is the next? Okay, refine primary key as required for data granularity. Now what is the granularity? Granularity mean the level of detail represented by the values that is stored in the table row. And if we say that our data is atomic, then or all attributes are atomic, then they are representing the lowest level of granularity. Yani granularity is fine. Okay, like when we, if you look at assignment table, here in this assignment table, it uses assign hour attribute to represent the hours worked by an employee on a given project, like which employee on which project work on how many hours, and project num and employee num is the primary key of this table. Okay, now for example that this primary key is good for representing the total number of hours an employee worked on a project since it starts. Okay, since project start, how many total number of hours this employee work on this project. Okay, in that case this is good primary key. But if we want to keep record of, or if we want to insert like a project, there is you know employee, you know, he is working per hour every day, like in morning and then in evening also. So in morning he worked as 4 hours and in evening 5 hours, and now we want to keep record of this thing over here. So project num, employee num will be same. If we want to add another entry for number of hours he work, or number of hours he work in a week, number of hours he work in a month, or number of hours he work in a day, like we want to keep record of daily number of hours a employee work on this project. So in this case, daily number of hours a project an employee work on the project, you cannot keep record of it. So in that case, because if you want to add two record with same project, same employee number, day 1, day 2, day 3, so project number and employee number will be repeated. So this is not a good primary key in that sense. So what we did is we added a, or we include a surrogate key over here in this table. Instead of project number and employee number, what we have now, a primary key over here. Okay, project number, employee number is a foreign key. When we improved design, we added here a surrogate key assignment number, and it increase, you know, monotonically every time when you enter a new record. And you will not have an issue if you add a multiple number of assign hours for a same employee working on the project. You can add as many entries as you want. Okay, the next thing is maintain historical accuracy. Now in the current form, if we see that you know, job charges per hour, in this case they just show the current charges of that programmer is charging 35.75 per hour. System analyst is charging 96.75 per hour. But what happened if charges per hour has been changed from system analyst, because charges per hour does not remain same forever. This value can change. Like after maybe a year, system analyst charges per hour has changed to $100 per hour. So what happened is, in this table we will change this 96.75 to 100. But what about the historical data? It will not keep record of the historical information, like in that particular date what was the charges of system analyst per hour, you know. So in this current scenario, it is not keeping record of the historical data. So in order to keep record of historical data, what we do is, in assignment table we add this attribute, assign charges per hour along with assign hours. So assign charges per hour will be added over here along with the date. So if even in this table it has been updated, but historical information is still present over here in the assignment table. Okay, so we add this assign charges per hour attribute here in assignment table to keep record of historical data. Okay, now if you see here this attribute, we add here a new attribute, assign charges, in assignment table. Now this assign charges is a derive attribute. How we calculate this attribute? We multiply assign charges per hour multiplied by assign hours, and we got these assign charges. Okay, assign charges is a derive attribute, and we permanently add this derive attribute in our table. We keep it as a part of it. We can derive it in the and at the time when we need it, but we prefer to keep it as a permanent part of the table. Why? Because we want to save time from processing. Whenever we need this value, it is already available for us. We don't have to calculate it on runtime. So we are storing the derive attribute in our table as a permanent part of it. Clear? So these are, now you can see that in this previous example we make changes to improve the database design, and when you are going to improve database design, you have to go through step by step. Evaluate primary key assignment, naming convention, all these things. Okay, and I have given you with example the description of it. Any question? So let's go to then denormalization. Okay, surrogate key. Surrogate key is also an important thing. When we need surrogate key is good in case if your primary key is a composite key and it consists of many attributes, like your primary key consists of 4 attributes. So it is very difficult to manage it. So they said that if your primary key consists of many attributes, so it would be better to go for surrogate key. First condition. Second condition, you can also go for surrogate key like we have seen over here. You know, which key here is surrogate key that we added? Job code. Okay, because job description is a detailed thing, and there is a problem over here, like it can create issue when we are adding over here in this. So what we go for it, like we introduce job code as a surrogate key over here, because primary key attribute, which is job description, might simply have too much descriptive contents to be usable. Okay, it is too descriptive, so okay, why not add a surrogate key? Now what is a surrogate key? Surrogate key is a system defined key. Okay, and it is automatically generated and managed by the database management system by itself. Okay, and when you add surrogate key, it is always numeric, and its value is automatically incremented every time when a new row is entered into the data base table. Okay, but here in this case, like job code is a surrogate key, and job description, if you see, both time job description is programmer, and two job codes are generated out of it. So there is a chance for such kind of error from data entry operators who are entering data. If you look in this case, it is not violating any of the rule, because job code is unique for both the rows, although the job description is same. So when we are using surrogate key and there is a chance of such kind of problem can occur, then you must add another constraint on your attributes which you want to be unique. Like job description, we know that job description will never repeat itself. Every job have its own job description. So what we can do is, so such situation does not occur, we add a constraint on this attribute. What should be the constraint on this attribute? The constraint is unique index. Constraint is unique index. When we go for SQL and we define table, you will learn how to add constraints. But here, when you are using surrogate key and some other attribute, you don't want it to be repeat like in this case, then you add a constraint unique index on that attribute. Like on this job description, we have this attribute. So we can make sure that in job description table there is no repetition of values like here in this case. This thing should not occur. We try to compare the normalization with database design. They said that normalization is not a database design itself, but it is just a part of the database design. When you are creating database design, you need to make sure that whatever entities you represented over here meet required normal form before you create table out of it. Like you have a ER diagram, and in ER diagram, when you are actually implementing tables using DBMS, make sure after that you normalize your ER diagram, and your ER diagram conform to the normalization rules before changing it to tables, actual table structures. Okay, many real world databases have been improperly designed or burdened with anomalies, and then you got a job for database designer and it asks you to redesign and modify the existing database, although it's more difficult to modify the existing database instead of creating a new good database design from scratch. Okay, like here we have an example: initial contracting company, ERD, employee and project table, and now you have to okay, from this they create this ER diagram. Okay, if you look over here, look, each employee okay, each project requires many employee, and each employee is assigned to many project. So here they try to show this relationship is assigned to and requires one to many, one to many. Although it is not one to many, but it is many to many relationship between employee and project. In actual, these two relationships are redundant. There should be only one relationship, and connectivity should be many to many. Okay, but if you have many to many, like in exam also, many employee work on many project, so in that case what you have to do, or many employee assigned to many project, you have to create here a new entity, assignment entity. Okay, here we add a new entity, assignment entity, and add it to both employee and project. And here we create another relationship between employee and project for manager, which employee is the manager of which project. And this is the database out of it. It was just an example. Okay, then another thing that we have is denormalization, which is opposite of normalization. We know that if we have optimal database implementation, then all tables should be at least in third normal form. And when a table is in third normal form, it means it has minimum redundancy, and there is no chance of any insertion, modification, or deletion anomalies in the table. And when we are creating normalized relation, that is an important database design goal, then we know that we also need to consider processing speed and processing requirement for the database design as well. Now the problem with normalization is that tables are decomposed to conform normalization requirement. You see that when we perform normalization, we divide one table into multiple tables. Like we start with one employee table, and out of it we create 4 tables. Then our normalization completed to third normal form. Okay, so normalization is decomposing a table to multiple tables, and number of tables expands. Okay, so when number of table expand, then in order to generate information, data must be put together from different tables, and we have to join these table, and joining a large number of table takes more processing power and additional input output operation. And what happened as a result, your system speed will be decrease. So they said that most of the time your DBMS system are able to handle join queries efficiently, but rarely or occasionally there are some circumstances where you have to go for denormalization in order to increase your processing speed. Okay, in order to increase your processing speed, you have to do denormalization. Denormalization is opposite of normalization. What you do in denormalization, you join table together. When you join table together, it means you are increasing redundancy. Okay, when redundancy increases, chance of anomalies also increases. There is a chance of database inconsistency also increases, but on the price of processing, increase processing. You want more processing, efficient processing, you want to get answer of your queries fast, so you just join tables together. Okay, so what are the defects of unnormalized table? If when we perform denormalization, it is possible that we go to unnormalized table structure. So what are the defects of unnormalized table? Data updates are less efficient, because program that read and update table must deal with larger tables, because you join tables together. Okay, you perform denormalization, table become larger, so data updates are less efficient. Indexing is more cumbersome or difficult. Why? because it is simply not practical to build all of the indexes required for many attributes that may be located in single unnormalized table. Indexing is required for efficient searching through database. Okay, indexing is a technique that is used to efficiently search from database, and if we perform denormalization, indexing also become difficult. And third thing is, unnormalized table produce no simple strategies for creating virtual tables, which are also known as views. Okay, how we create views, that we will discuss in our SQL and advanced SQL chapter. Okay, data modeling checklist. We know that when we perform data modeling, it translates a real world environment into a data model where it represent real world data, user, processes, and their communication or interaction between them. When we perform data modeling checklist, it helps to ensure that all the tasks required for data modeling are successfully performed. So here we are some of the data modeling checklist. Okay, business rules you need to define. Okay, business rules gives us the overall flow of information in the system, what are the requirements of the system and all that. Based on that, you write business rules, policies in the system. Then data modeling, okay, naming convention, entities, attributes, relationship, you did. And after that, you know, you come up with ER model, and there are some, you know, properties for each of it is given over here, which we have already discussed in all the previous chapters. And our normalization chapter finish over here. Okay, thank you so much. By the way, I have deleted from the slides related to BCNF and fourth normal form. Why? Because we require until we want to go until third normal form. So if here in summary there are few things about four normal form, we did not go for it. Thank you.